Welcome everyone to this first tutorial of how to create an animated NFT collection. My name is Victor, also known as Chiwi, and I am the co-founder of Capybaras Country Club, and we wanted to make this first video so you can know all the process that we have been through the creation of our collection. So the idea is to teach you guys all the tools that you need in order to create the collections, all the techniques, all the software, and to explain you in detail and how to use each one of the projects that we have prepared for you, so you can have an easy step-by-step guide to create your animated collection, and you can be more focused in the creation or in the implementation or your utility, and you don't spend so much time as we did in order to create the collection. So we're going to take a look at two projects that you're going to need in order to set up all your workspace. So first, we're going to talk about this CCC Metadata Generator. Actually, this is a fork that we made from HashLib's art engine, and the idea of this fork is to make it faster. I don't know if you already know the HashLib's art engine, but actually it's a code, it's an algorithm created from HashLibs, that will allow us to create the metadata for the NFTs and also to create the image for the basic collection that uses static images. But actually we made the fork to avoid the step of creating the images, so you can have only the random generation of the metadata in the JSON file, and you can have a faster algorithm to do that. So this is the first project that we're going to use, and the second one is going to be the CCC-Engine. And this project, it runs in C++, and this is the project that we're going to use to apply the animations that we're going to create in Spine. So for Spine, you have actually two options. This is a software that we're going to use to create the animations of each one of the traits, and you essentially have two options. You have the essential package, you have the professional package. So with the two options, you are going to be able to create the whole collections, but with the essential package, you are going to be very limited in terms of what kind of animations you're going to be able to create. Actually, we recommend the professional package because most of the features that are available in the pro version and are not available in the essential are very useful, and we actually use it almost all of them in our collection. So we recommend this version to create your project. The examples and all the tutorial that we're going to create is going to be made using this professional license. Okay, so first of all, you're going to need to clone these two projects. I already have the two projects cloned. So we're going to start with this one, CCC Metadata Generator. I have already here the project. Okay, let's open a terminal. So as I said, this is a fork version of the HashLib's art engine. So you may notice some difference in how we define all the traits, but basically you're going to be working in a single file that's going to be the config.javascript, this one in the source folder. So all the modifications, all the configurations, you're going to need to do it in this file. So for example, here you can find the general information of your metadata, like for example the name of your collection, the description that is going to appear in the metadata file, and then you have, for example, the size of your collection. This is the information in case that you're using Solana as your main network. But for us, if you're using Ethereum, you only have to modify this. You can also add more data to your metadata. For example, you can add some kind of website or any kind of node. You can actually add another variable and add it at the end in the metadata. But for the moment, we're going to use only these three ones. And then we're going to use the layer configurations object in order to define all the traits that we're going to use in our collection. So actually we have some kind of modifications here in order to handle conflict traits. For example, if you have some kind of traits that have that cannot be put together in the same NFT, so you can define over here. This is an example. You can define over here the traits that have a conflict. In this case, any kind of glasses has a conflict with the laser eyes. So putting that in these variables, the algorithm is going to avoid the creation of an NFT with any kind of configuration within these two type of traits. Okay, so we were going to be concentrated in this object, layer configurations. Here we're going to create and define all the traits that are going to be in our collection. And we're also going to define the weight and the rarity level of each one of the traits. So for example, here we have the background. It's a very common trait. For this kind of trait, we have a flag that we can set up that is to avoid actually that this trait is considered in the DNA of the metadata. So for example, the background, we don't want it to be one of the traits that define the rarity of an NFT. So for this particular case, it's very useful to define this type of trait with this flag in order to tell the algorithm that don't consider this trait in the rarity of the metadata. For the rest of the traits, for example, there are traits that you may already know for our collection. We have, for example, the body, the face, the eyes, mouth, and the head. So here you have like an example of some traits that actually exist in our collection. So you can use this as a template. So here you have the name that is going to be appear in the metadata file. Be careful because actually you can this step you can redo it multiple times, but you have to take into consideration that the name that you see over here is the actual name, the real name exactly that you're going to see in the metadata on, for example, Opensea. So here you can write the name of your trait. Here in the name of the base object, you can define the type of the trait. And here in the weight, you're going to define the weight of the ratio of appearance of each one of these traits in your collection. If you need more explanation of how this algorithm works, you can refer to the original repository of Hashlips, because it have a very extended tutorial of how to use this algorithm. Actually, you're going to see some difference, because in the original algorithm, the weight are not defined over here, are defined in the file name of the images, but actually it's the same concept. So the higher the value of the weight, the more probable it's going to be this trait in the collection. For example, to do an example here, the percentage of appearance of this trait is going to be 100. divided by the total amount of all of the trades in this category. So for example, here we have 1, 2, 3, 4, 5, 6, 7. So we have 100 divided by 700. So it's going to be something around 12%, something like that. So this is the percentage of appearance of this trait for this category, for example, for the body. So you can play around with these values to see if everything is okay within your collection. But for the moment, we're going to create one example metadata using this template. It's very easy to add new traits. Actually, you have only to add a new line. You change the name here, you change the value over here, and you're ready to go. So we're going to create, for example, a collection of 10 NFTs. Here you define the size of the collection. So to do that, once you download and you clone your project, you're going to need to install all the dependencies. At the beginning, you're not going to be able to see this folder. Actually, I'm going to delete it so we can reinstall all the dependencies. And the build folder, you're not going to be able to see it at the first time, so we're also going to delete that. So the first thing that you're going to need is to run npm install. Okay, so here if we refresh, so you can see we have actually the folder node modules with all the modules and all of the dependencies that we need in order to run this algorithm. And then you're going to need to run this file is the index JavaScript, but something that you have to verify this first is the version of your node package. So you're going to need also node, so you can verify the version with this command. Be sure to have at least the 16 version of node. If you have any kind of issue during the next step, that's probably because you're not in the final version or for example the 16 version of node. So the next step is to run the main algorithm by running node index.js. So once you run that, we're going to create the metadata for all your collection. So as you see, it's very fast. If you see the example of the original algorithm from Hashlibs, it takes a little bit more time, and it's going to be actually faster if you create, for example, like 10,000. You're going to see that it takes actually some seconds to create the whole collection. So that's the advantage of not having to create the image in this process. Okay, let's get back to our example of 10. It's going to be easier. Okay, so the metadata is going to be created in this folder here in the build. Once you run this command, the build folder is going to appear, and you're going to see, like for example, this image folder is empty, but the JSON files, actually you have to see the metadata of each one of your NFTs. Okay, so for example here is that's how it looks like, and the metadata file for one NFT. So you have all the traits, the trait type, all the traits value. You have the description that we said at the beginning, and that's the IPFS URL of your data, of your GIF. So for example, right now we have this update to update, for example, variable here that's going to be replaced once we upload all the GIF to IPFS. So for the moment, let's keep it like that. But something that you have to do at the end of the whole process of launching your NFT, you're going to update this information, and you're going to be using the update information algorithm within the project to update this information. And this, you can do that by running node utils update and env. So you're going to update this information with the URL. Actually, you can see that in the original project tutorial, but this is something to keep in mind for the moment. So for the moment, we're going to leave it like that. So we have, as we said, the metadata of the 10 NFT that we'll recreate, and we also have this file that is going to contain all the information of all the metadata of the NFTs together in one single file. And this is the file that we're going to use for our next step, for our final step actually, because we're going to be reading this file in order to apply all the traits to our GIF. Okay, so that's the first step to use this project. So the thing that we have to keep in mind is the final result. So as we said, we're going to look at this file here. We're going to copy that, and we're going to paste it in the CCC-Engine. That is the second project that you have to clone actually. So we're going to paste it in metadata folder. So we're going to replace the old one. Okay, so once you paste it here, we are done with the first project, with the first step of creating the metadata of your collection. So for the moment, we're not going to need anymore this project until the next step, where we're going to update this information. Let's go to Spine, because this is the second step, and this is where we're going to create the animation of all the single traits. So something that you need for Spine is the input art, so the art of the traits. Okay, so we're going to share with you some techniques for this kind of collections. For example, something that you're going to need actually is to split all the image in moving parts. What do I mean by moving parts? If you see like a single static collection, like images, so you're going to notice that each trait actually is an image in a single layer of the file. So you can put all the layers together and have the single NFT. So for us, each trait is going to be composed by several images. Why? Because as you already know, this is going to be like a lot of moving parts. We're going to have a lot of moving parts. So we're going to need to have a single file for each moving part of the trait. So for example, we have this for the astronaut. So we have this piece of the suite. So you can see we have, for example, for the astronaut, we have 3 images for the same trait. And you're going to need to ask to your artist, or your artist need to provide your traits like that in order to be easier, you know, in the next step of the animation process, to animate one of the single traits. So this is an example for the astronaut trait, but you can see, for example, this one, we have several images. We have, for example, here the ring. We have this to hold the ring, and each moving part is going to be split in a single image. So once you do that, we're going to import all these images in the Spine project, and we're going to explain you how this tool works and how to create the animations for each single trait. Okay, so this is Spine. This is like where we're going to create all the animations for all the traits. So here you have like the navigator or the file explorer for all the elements in your project. Here you are going to visualize actually all the images and actually also the each one of the animations. Here you have some tools to manage the basic transformations like rotations, translation, scale, something like that. And here in the top left, you can switch between the main menu and actually between the animated animation setup. So for example, here we're going to create and set up all the animations for the images. And okay, so we're going to back up to the main menu. The things that you need to understand of this tool are mainly three things. The first one is how the bones works, and what is a bone is the first thing that you need to understand. The second is how the skins works in this project, and something that is important to keep in mind is the draw order of the image files. Let's talk about the bones of this tool. Spine, it works actually in bones. Okay, so the bones actually are going to define each one of the movements that we're going to have in our project. So basically the bones here, they works like in levels. For example, let's visualize here all the bones that we already have in our project. As I said, the bones are going to determine the movements of the whole avatar in this case. Something that we need to understand first of all, how is our avatar composed? For example, in this case, we have like a chest with a head. So for us, we're going to create like two main bones that are going to define the body of our avatar and are going to define the main movement of our avatar. What do we need to do in order to select where are we going to create the bones and how to place or the bones or the main bones of our avatar, and how to define the movement that we want to have in the end. So first we have to define or to clarify how our avatar is going to move. So for example, if you already know our collection, you know that we have like a loop with the idle animation. So for example, we have this kind of movement where the body have a translation and the head of our capybara has a very slight rotation, to front and to back. But for this kind of animation, actually we're going to need to create two bones, one to define the translation, because remember, the bones are the objects that are going to dictate the movement of the images. So we're going to create the bones, we're going to assign some movements to these bones, and then the image are going to follow this movement. So that's how these tools works. We have two things like an skeleton. So in this case we have the chest to move with the translation, and then we need the head to move like with a rotation over the translation of the head of the chest. So for this we can create, for example, actually we already have the two bones, but if you need to create from the beginning, so we have two methods. The first one is to select this bone here, over here, all the things that have, for example, like this cross, or you're actually going to see like this kind of element here. They are bones. Actually you're going to distinguish because they are colored. So this one is the main bone, so it's going to, all the movements are going to be attached to this main bone. So it's not recommended to add movement to this one, because we want actually to have all the animation based on one single point of reference, and this is going to be this root. To create a bone based on this root or on this point of reference, we have two choices. The first one is to select this one, go to this button over here in the bottom of the screen. We select create. We place our mouse at the beginning of the bone. We click, we hold the click, and when we have the desired size, we release, and then we have our bone. So for example, here we have this bone in this level, and this level means that this bone is referenced to this bone over here, the root. For example, if we have a movement of this bone, it's not going to be affected by the movement of this base bone because it's in an upper level. If we want to create a bone that that the movement is referenced from this bone over here that we already create, we have to select this one. Then we have the same procedure. We create here and we click here on the create button. Then we hold and we release. And in this case, you see that we have two bones. The bone 2 that is referenced to the first one, the single bone over here. Let's see how these bones react to each other. If we select this second one, let's change and avoid to create another one. Here you can control the movement of each one of the bones. For example, we can rotate it by selecting the rotate here and then moving the bone left to right. So as you can see, this bone is moving by itself. It does not affect the movement of the previous one, but if we already move the first one that is in an upper level, you see that this bone is going to affect the position of the second one. Why? Because it's in a lower level. Okay, so how we can make this work to have our avatar moving as we want. So we know that we have this chest that's going to move with that translation, and over this movement we're going to need to have the head, because as you already know, the head is attached to the chest. Then the head is going to have its own movement, but it's going to be based on the movement of the chest. So for our case, we're going to add a translation to this one, and we're going to add a rotation to this one. And another important thing to have in mind is how can we to attach this image. For example, because we have, in this case, we have the base image, how we can attach this image to the bones and to tell the image that follow the movements that we already create here. Okay, so let's get back to the first bone that we already had at the beginning. So let's create it again. So I have this one to dictate the movement of the chest, and we have a second one to dictate the movement of the head. Let's show the bones over here. So you see that the bones that we already just create are in red color, and the bones that correspond to the real project actually are in green. We're going to add actually something that is called an slot. So we have to actually click the bone, the base bone, where the image is going to be referred to, and then we have to do that here, new slot. So the slot is going to be, actually you can have any kind of name, like for example base, and then you have a slot that is referent to a bone. So in this case, for example here, we have actually the image explorer. The first point is to add the image to be actually visible over here. To do that, actually you can search the path of your files. I already done that, so it's going to take some time. It's going to load to verify all the files that you already have in this path. It takes actually some seconds, so you're ready to go. So actually we already create this slot. Let's add actually the skin, the base skin that we already had in the past. So the procedure is to click on the image, hold it, and drag and drop here in the slot that we already created. Normally you can have some kind of issues of the placement. To fix that, you can center all in the origin, like 0, 0, and there you go. So right now, what do we have? We have this image in this slot, and we know that this slot actually is based on this bone that it corresponds to the chest. To do things more clear, actually we can change the name of the bone. This already exists, chest demo, and then we have to add head demo. Okay, so right now we have this image, as we already said, reference to this one. That means that if we move this bond, right now we're going to select the translation transformation. So you see that it's already attached. But actually this bone for the moment is attached only to this bone. For example, here if we have a movement like the rotation, we see that nothing happens, and for the rotation nothing happens. So what do we need to do in order to attach this image to several bones, not only one? For example, in this case it's simple, only drag and drop, but to have an image to be deformed by several bones, actually we have to use one tool that it comes only in the professional package, and it's called the mesh. So to create a mesh, actually the procedure is simple. We have to click on the image that we have to create the mesh from, and over here in the bottom we have to select mesh, edit mesh, and then we can create a mesh of the image by defining the points that are going to describe this. But actually I think it's very useful to use this tool that automatically create the external points of the mesh. You can define actually the detail level. So for most of the time, and the detail level of 50 is going to work well. If you need more detail, actually you can increase the detail level. It's going to be very fast, but for us, let's keep it at 50. Okay, let's click OK, and then we can, yeah, actually here you can be more you can add more detail to the mesh in the case that you already have, for example, like 3D image, or actually do the image that you want to create like a 3D effect. Then it's going to be useful, to create more points to define the mesh or the object or the structure of your images. But for us, as we have like 2D image, and we don't have to, or we don't want to create like this 3D effect, for the moment it's not relevant to modify the internal points or the internal nodes of our mesh. Okay, so for the moment we have the mesh that is based for the moment in this single bone. So what do we have to do in order to apply the transformation of this bone and this bone to our mesh? So we select the mesh that we already create, and here we're going to bind all the bones that are going to affect our mesh. So in this case, it's going to be chest demo and head demo. Okay, so you see here that it's calculating weights for the mesh. So if we can see over here in this menu, weight, by selecting before the mesh, then going to weight, you're going to see like some nodes or points that have some colors. So the colors represent the weight of each bone for each kind of node of the mesh. That means that, for example, for these points over here, they're going to be affected more by the movement or the transformation of this bone that they're going to be affected by this one. So for this case, the automatic assignation of weight works pretty well, because, for example, we need the head to be affected by only this one, and we have the body affected only by this one. So for example, here, if we select the bones, and we have here to define some kind of movement. So if we, for example, try with the rotations, the bone rotation, you see, for example, here the upper level of the image is affected mainly by the movement of this bone. If we are going to do, for example, translations, it works pretty well. And to edit actually the weight, we can go back to, for example, the weight menu. We can select, for example, like each one of the nodes, and here we can modify like the percentage of weight that's going to have for each one of the nodes. Actually, we can have this for several nodes. For example, we can have, for example, bind, and we can add another one, you know. Get back, and for example, we can select this kind of node. We select natural, and we're going to add more weight to this kind of bond. So if we see, for example, we have like purple, 33%, 36% actually, and we have, for example, the blue 60% and 5% of the head. So that's if that's the case, that you have, for example, some images that are going to be deformed by several bonds. That's how you can do it. And to remove is simple like that. And if you want to modify the weight for several bonds, several nodes at the same time, you go back to this menu. You can select all the nodes that are going to be modified, and here you can play around the percentage, and that's all. Okay, so once you have, for example, your mesh that is linked to the bonds, the last thing that you have to do is to add some movement in a loop for the bonds. So for that, we're going to pass to the animation. Here you are going to hide actually all the bonds that already have a movement, and we're going to select the bonds that we have we're going to create the movement for. So for example, over here, we're going to create a translation, in this case, in this example, for the chest. So how do we do that? So let's pause this animation. So normally we want to create like a perfect loop. For example, for that, we already said that we want to create a translation. So we're going to select translation over here, and we're going to fix the first position. And as we already said, we want this to be a perfect loop, so the initial position and the end position are going to be the same. Here we're going to set up the same position from the beginning to the end. So over here we can set up the position, and the initial position and the final position for the animations are the same. And in the middle, for example over here, we're going to set up a position that is the same, but actually we can modify it using this menu. Actually, I can drag and move all of these points to the position that we want. This corresponds to the X translation, and this one corresponds to the Y translation. So for example, let's add only a basic translation, nothing too complicated. Okay, so in this case, we have this kind of movement. For example, you can see. Actually, this is a very basic example. We have like this kind of robotic movement. Let's play to see how it looks. We have, for example, this kind of robotic movement and to linear. To modify that, we're going to select all with Ctrl-A, sorry, and we're going to add automatic curve to our movement. Okay, so even if it's not perfect as the translation that we wanted to have, I think that we can use it as an example of what we need to create. For sure, we have to modify these points a little bit to have a smooth transformation and smooth translation. But to demonstrate the purpose and the basics, I think that it's okay. So let's move on to the second transformation that we need. So for the moment, if we play this animation with only 3 points, remember that you can set points in several frames of the timeline. For example, we can click this one, copy with Ctrl-C, and then we can paste it, in another frame. And then these other points we can move around. We can change the curve. We can change the end point, something like that. So for the moment, we're going to leave that as this basic transformation. So if we play that, remember, we're going to have this simple looping animation. So let's move on to the second one, that it's going to be the rotation for the head. Remember, you have to select the bone that you want to modify. Then you place the cursor in the frame that you want to set up the key. So in this case, we're going to move with the rotation. So let's set a key for the rotation in the initial frame, and let's say the same point to the final frame. In this case, the 60, and then we can set several keys in the middle. And remember, we have always the option to modify these keys. Let's keep only 2 keys in the middle. Let's delete this one. Okay, so let's limit the transformation from, let's say, this is too much rotation. Let's say only a little bit like that, and for the other side, only a little bit. Here you can set up with this option. We can limit the values only to the range of values that you are actually using on your transformations. Okay. Okay, for these 2 values, as we did at the beginning, we can select all the keys and use this option to automatically set the curve, so we don't have some change to difference once we reach the top at the beginning of the timeline. So let's see how it looks. Okay, here we have some kind of I think it's not looking bad, but I think that we have some kind of artifacts over here due to the mesh, to the weights that we have in the mesh. So let's fix that. Something that is very useful when you are using mesh for image that depends on more than one bone is that actually you can select all the weight, and to avoid this kind of strong difference, you can use this option to smooth actually the difference between several nodes. This you can use several times. And if we go back to the animation, we're going to see that right now here, you see the change is not so different, and we are not having the artifact that we had at the beginning. Okay, so that's an example of a simple animation. Actually, we're going to delete this animation that we already did. The only difference between this one and the original, this one, that's the original one. So let's play it up. The only difference between the 2 phases, the 2 steps that we already did, are the curve of the transformations. In this case, the translation. And if we see, for example, so this is the chest, though you see the curve are slightly modified here. And if you see, for example, the head, we modified a little bit the curve to have like a smooth animation to the right and to the left. But this is actually the only difference from the original animations to the animation that we already did just right now. Okay, so let's keep the original one. For now, we're going to delete these changes. Okay, so the last step to follow is the skin process, because the skin process is the tool that is going to allow us to actually to apply the traits into the CCC-Engine that we're going to talk about the next step. Right now, we already have created a lot of skins. For example, when you open your project, it's going to be empty. I already added a lot of folders and some skins. To add is very simple. You can use new. First, we have to select skins. Then we can use new skin. We can create with a name, and we're going to add the skin. going to delete. And to create the folders, actually it's the same thing. New folder, and it's going to create a folder, and inside the folder you can create several skins. So the skins are like it says, is actually it's like a wearable that we're going to put into our avatar. It's like an accessory, something like that. So something that we recommend is to create one skin here where we're going to create and to make all the animations. You're going to be selected in this skin, and in this skin we're going to make all the steps that we already did to create the single idle animation. We're going to be using this skin also to create the animation of the single traits. And once we have all the animations created in this skin, we're going to transfer the single animation to the corresponding skin. Okay, so let's make an example so to be clear. Let's say that we have a trait that corresponds to an eye, or better, let's say that we have a trait that corresponds to the body of our avatar. Okay, let's go to this bone where we have grouped all the traits for the bottom of the avatar. Here we have the astronaut. So how we can create a trait for the bottom? Here, this trait actually it's helpful only to group all the traits that are going to belong to the bottom, but you can create the slots directly in the chest bone. Here we have this bottom bone. We have to select this one. We're going to make the procedure that we already did to create the main avatar. Let's create a slot. This one's going to be called Astro for astronaut. And as you already saw in the beginning, we have 3 different images for this trait. So let's duplicate with this button over here. Right now we have 3 slots that corresponds to the trait astronaut. The next step is going to the images. Here is body, and we have these 3 images that correspond to this trait. Let's select, drag and drop. Perfect. We have to select 1 image per slot. Like that is going to work. Okay, here is to hide or to show the images. So here we have a problem in the draw order. So to fix that, it's simply going to draw order menu and change the order of the images to fix the problem. So right now we have all the slots for the trait. Let's say that we need an animation for a single item. Let's say for this one. It's easy. Remember, you can create a mesh over here, edit mesh. You can trace an automatic nodes, and once you have this, you can always from this bone create a new one. Let's say over here. And once we create this bone, we come here to the mesh, bind, select the bone that is going to be moving actually these images. In this case, only this bone that we just created and the chest bottom. If we have the weight, we see that this image is being transformed or is being animated based on 2 bones, the chest and the bone that we already create. If we want this image to move in a specific form, we have to go to the menu and modify or add a special animation for this bone. As you saw, we can add like rotations, translation, scales, and once we add this, our image is going to be transformed based on the transformation that we desire. But we already saw how to do that, so we're not doing a second time. For the moment, I would like to teach you how to add these traits to a skin. Let's say that we don't have this trait this skin astronaut. Let's delete it. And we have to create one. So here we follow the steps. We create the 3 slots. We add to the slots the 3 images, and we add the transformations or the animation for the pieces that requires to move. In this case, only this one. Let's say that we want static and a static animation for this one and for this one. Okay, so the last step is to create the skin, because the skin is the item that we're going to apply to the GIF. How can we create a skin? New skin. Actually, this name has to match perfectly the data in the JSON file of the metadata. So let's call astronaut. Okay. We already create the skin. That's good, but we haven't applied actually this slot to this skin. How can we do that? We have to go back to the first skin where we actually made the animations. We have to create for each slot something that is called a skin placeholder. So new skin placeholder, you're going to see this small orange icon over here. The name is going to be by default the same as the slot. So let's do OK. We're going to do the same thing for the other slots. And once we have this, we have to add it to the skins placeholder. Okay, so for the moment, we have assigned the images, the traits for this skin. Now we have to transfer this one to the skin that is going to be the real trait. For the images, the steps are simple. We have to select all the images types. Image, you can see that the icon is like a blue square. So we're going to select all the images and we're going to duplicate. And for the mesh, you're going to see that you have like these small nodes with this orange line over here. So for the mesh, we're going to create something that is called linked mesh. So a linked mesh is not a copy. Actually, it's a mesh that is going to be modified every time the original mesh is modified. So we create it, and then we have to change to the trait that we want to apply these images. We change this, and when we change, we can drag and drop each one of the elements to the skins placeholder. So you can see right now that this skin only has the image that belongs to the astronaut, and if you go to the animation menu, you're going to see that it's moving as we defined in our previous menu, in the main menu. Here you can see that each time that we apply only the astronaut skin, is going to add to the avatar only the image that corresponds to the astronaut, taking into account the movement or the animations that we already applied to this skin. Let's delete actually all the changes that we already did. Why? Because we already have actually the astronaut skin over here. You can see that actually it's the same thing that we already did in the past. These two images are static, and this one that corresponds to the to this section. Actually, it's going to, if you go to the animation menu, we're going to see that we have a slightly moving over here movement. So once we pass to the astronaut skin, it's nothing. Let's transfer actually this movement to the astronaut skin. Remember, for the image we're going to copy, and for the skin, for the mesh, sorry, we're going to create a linked mesh. So we change to the skin that we already created, and we transfer all the items, simply like that. And if we see the animation, see we have the slide animation over here. So remember, each time that we are going to apply in our CCC engine and skin, is going to apply only the items that belongs to this skin. In this way, if we have in the metadata, we have a type of capybara, okay, natural, a type of bottom trait. If the bottom trait says astronaut with the movement, then the CCC engine is going to apply this single trait to the avatar. Once we have this structure, one skin per trait, and each skin has all the elements inside which with its own movement, the last step is to export the project and to apply all the animations based on the metadata using the CCC engine. We're going to spine export. It doesn't matter the configuration over here, it's going to export everything. One thing that is important once you export the project is to be sure that for all the traits, all the skins, this element, the skin placeholder, is not hidden. Here you can have, for example, the slots can be hidden, and it's not a big deal if you don't see anything, but this item over here, the skin placeholder, cannot be hidden, because if it's hidden, when we're going to try to apply the animations in the CCC engine, we're not going to be able to see anything in the final GIF output. So be sure that this is always active for every kind of slots, and if you want to clear out the vision over here, you can always hide only the slot and not the skin placeholder. Okay, so to export, let's go over here to the top left, export. We have several options. We can, for example, export only a GIF of this animation specifically, or we can export actually the whole information of the project, and this is what we're going to do. We have two options. We have the JSON file and we have the binary. It's better if you select the binary because it's faster, it's lighter actually, and it's better and this is the input that requires actually the CCC engine. Okay, so here you have to select only an output folder. The extension you have to leave it like that. The scale extension is good. And here in the pack settings, this is the configuration that we already have, like the min and the max size of the atlas. It's going to be okay if you leave it by default. Something that is required is this suffix and scales. Where is the scale factor of the images? For the rest, you can leave it by default. It's okay. And it's easy. You click on export, and you are going to have in a minute the skeleton file and the atlas file. Okay, so now it's finished, the export process. Right here you're going to see, like, for example, a lot of warnings concerning you have several slots hiding. There is no problem if there are only slots hiding, but for example, if you have some kind of skins placeholder hiding, right, you have to check that out and change these configurations and re-export, because as I already said, if you have some skin placeholders hiding, you are not going to be able to apply the animations in the last step. So only slots hidden, no problem. Okay, so let's see in the CCC engine how the exported data looks like. So we have these kind of elements. The CCC demo skeleton, that's the skeleton file. All the project information is in this file. And here we have, for example, all the traits in this atlas. Okay, so going back to the final step in this algorithm, we're going to apply based on the metadata information, is this one, and we're going to apply all the frames of the whole animation and export it as a GIF format. Okay, so here let's actually you have to create like a build folder. Already created, I think. Yeah. So in this you have to only to build the project with CMake. Link with make. I already built it, but the procedure is it's simple. You may have actually some missing dependencies on libraries like FF and PIG, but if you have any kind of missing libraries, the CMake is going to tell what library are you missing, and it's going to be easy to add it. Okay, so let's see how can we use this engine. So here we have the help with all the options to run the program. So for example, here we can select by default, actually we can modify over here, but by default we're going to utilize the metadata JSON file with this name, and normally you have to change the project name to this one. For example, this is the project name and this is the name of the skeleton file that is going to be exported, and here in the algorithm you have to change that to your project name. Okay, so once you set up all of this information, the final quantity of your collection, all of this stuff, you can run actually this algorithm using these options. So here, for example, the most common are the initial frame and the final frame. So over here is if you have our collection of 10, it's the case of this example. We can start from the iteration 5 until the 10th, or you can start from the 2nd to the 7th NFT. Create initial 2 and 5, and you run it, and it's going to create the GIF from the iteration 2 to iteration 5. Another useful utilities are this one, the image output format. In the case that we want to create only a verification process, we have to see if everything is okay, and we don't want to wait to create all the GIF. We can create a first version only with images that correspond actually to the first frame of the GIF. In this way we can have like a faster result. We don't have to wait to the GIF to finish. So it's the same thing. We can merge all of the options, so we can do the same thing, but using the image option. So as you see, it's faster. The results actually over here in the results folder, image for the image and GIF for the animation. So let's see how it looks like. Okay, that's great. And for the GIF, actually we already have the thing, because before I run it with no options or quantity, so by default it's going to run all the metadata file. So it's the same for the images. For example, if we do without options, are going to create by default GIF and by default all the metadata file. So he already created, and as you can see, if we verify the metadata for the first element, so let's see, I think that we can see over here. So for example, we can verify that the background is green, neutral type, that's okay. The body will have hoodie, and if we see in spine, and we see the body hoodie, and we're going to show the hoodie elements over here. You see, actually the algorithm is applying this skin hoodie, that it's going to be the same name as it is in the metadata, and we're going to apply this one on top of the avatar. If you see, we can actually see the animation, and it has its own animation. So that's the concept behind the skins. We have small glasses, we have this kind of mohawk, and that's all. Actually, you can here see all the options available. We have another option that is really cool, is this merge. For example, you can merge all of the NFTs in a single GIF, and it's very useful, you know, for do like promotions. We can do merge, and we can select how many frames of each GIF we're going to take into account. Let's see that we want only 10 frames of each GIF, and we're going to merge all the GIF together in the same file. So I think that the default output is going to be the 0. Yes, hide this one. Here you can see that we use the merge, and for each animation we have only 10 frames, and the output is a single file with all the NFTs from the metadata. I think that you can play around with the other options. We have some useful elements to actually debug. It's very common that you made a mistake in the naming of the skin in the Spine program. Imagine that you did an error typing the name of the hoodie, and it differs from the metadata in the JSON file. You're going to see an error because the algorithm is not going to find actually this skin in the exporter data from Spine. So in this case, it's difficult actually to realize what's the trait that is causing the problem. In this case, you can run the debugger option, and it's going to output all the traits that you are applying to the skeleton. And if you have a problem, the last trait that is showed over here is the problematic trait. So you have also this option that is very useful, the debug option. Sneak peek is only to select a different metadata file. In this case, it's not going to pick this one, it's going to pick this one. If you have another set of metadata to show. I think that's it. So this is the last step. So remember, the first step is to create the metadata file, this one, using the CCC Metadata Generator, the fork from the hash libs. You can see more information in the original video. I can set a link in the description. And the second step is to create the project in Spine and create the animation for each single trait. Export all the project in binary. Remember, it's going to be faster. And the last step is to apply all of the animations based on the metadata file that you already generate in the first step. And with this, actually, you are ready to go. If we can see the GIF files in the CCC-Engine, we're going to have actually the GIF that corresponds to the final file that you can export to EPFS, actually to assign the data to your NFT. Okay, so I hope you guys enjoy and learn a lot in this tutorial. It's going to be the first tutorial. We know that there are a lot of technical things, a lot of different complex animations that we want to apply. We're going to create several tutorials to explain a little bit more in detail a lot of complex animations to your NFTs. But I think that this is going to be a nice start. Right now you know the whole process, the whole creation. Remember that you have access to all the code. Right now is public. You can actually contribute to each one of the projects. And if you have any kind of question, remember to pass by the Discord channel. you can tag me, you can tag the founders or another team member, and we are going to be glad to help you guys and to continue with this set of tutorials. See you in the next time, and remember to join the club.